Start.
I'll start with number 2. Oh no, yeah, 3 or something.
Okay, let's start with 3. What's the area of the circle? The full circle.
Pi r squared.
So what is it?
Pi r squared.
So what's R?
What's that?
So given an R of 9, what is the area of the full circle? Here's what I'm looking for. The area of the full circle is 81 pi, correct?
Yeah.
Okay. How much of the full circle do we have?
Like 3/4 of it?
Exactly 3/4 of it. And what we have is 270 divided by 360. In other words, that's the percentage of the circle that we have, right? That's 3/4. So 81 pi times 3/4. Do you have your calculator there?
I do.
I hate the fact that they put all the answers without pi in it, but
Yeah, they put it in meters.
no, what they make you do is use a number for pi. In other words, the answer should be 3/4 times 81 pi, not 3/4 times 81 times 3.14.
Yeah, you're right.
Okay, but they're only giving you these 4 choices, so you got to do 81 times pi times 3/4. What do you get? Your calculator has a pi key, right?
Yeah, it does.
Okay. What do you?
190.85, so 191 would be.
Okay, I'm not checking, but the answer doesn't matter to me as much as how to do it, the method. But what you're always going to do, in other words, they made this one easy by making that a right angle. Okay?
Yeah.
But let's say they made that 65-degree angle. Okay? Well, now instead of multiplying it by 270 over 360, it's a larger percentage of the circle. It's 295 over 360 is what, that's the percentage of the circle we would have if that was a 65-degree angle.
Yeah.
All right, where else?
I'll do 5.
Which one?
5.
Okay, let me move my sheet up here so I can, we're not going backwards, right? Ever?
Yep.
Okay. So I'll go all the way to the top here, take a screenshot of it. Now I can write on the drawing, which is kind of cool. I don't think I had this capability last time I worked with you.
Yeah, it helps a lot.
What is the approximate length of EG, the arc EG? In other words, from there to there, measured on the curve, what is that length going to be?
Oh, okay, I'm not.
Hold on a minute. Okay. There's a formula in geometry. What's the measurement? What's the arc measurement of EG?
52?
No. If this H was 52, then the arc measurement would be 52. But H is a central angle. It's twice whatever this angle is. It's 104 degrees.
That would be 104.
Okay. Now, what are we looking at? We're looking at what is this angle H?
That would be 52, right?
No, that'd be 104. In other words, the central angle is always equal to the measurement of the arc that it cuts out. So if we just found out that that arc is 104 degrees, it means that central angle is 104 degrees.
Okay.
And now there is a formula for arc length. It's r theta. If theta is in radians, you probably don't know what a radian is yet, do you?
Sort of. She's used to being a lot.
Okay. Well, if it's in degrees, it's just this.
Okay.
So that's the formula that's worth measuring. We'll solve it this way, and then I'll tell you another way to do it that I almost find easier. But it's hard to beat just plugging in. R is 15. That's EH. Theta is H, which is 104 degrees, times pi over 180. Give me a number there, and we'll choose one of the choices that fits that. Again, they're forcing you to convert pi. What do you get?
I got just over 27.
Okay, so 27 is the answer. Now, let's say you don't remember this formula. Now, a lot of people don't, because when it's in degrees, that's a complex formula. Okay? Well, what's another way I can do it? I can do it the same way I did the previous problem. I can figure out what the circumference of the circle is, right? What's the formula for circumference of a circle?
Pi r.
2 pi r.
2 pi r, yeah.
Okay? Well, so the entire circumference of the circle is 2 pi times 15, right?
Yeah.
What percentage of the circumference are we looking at?
The entire thing.
104 divided by 360. You see why? That arc length is 104 degrees. Well, the entire circle is 360 all the way around. So the ratio 104 divided by 360 tells you what part of the circumference we have.
Okay.
So now come up with that number, and better be the same.
Okay, let me see.
In other words, all I did is do it a slightly different way, but still it's got to come up with the same answer.
Yep, exactly the same, yeah.
Okay. Notice that doing it this way I didn't have to know that formula, the formula for arc length.
Yeah.
But I did have to know the formula for circumference of a circle, but that's really all.
Yeah.
And that's easier to, in other words, you should have memorized that years ago. I'm sure you did. So, yeah, so it's actually easier to do it this way, in my opinion, than it is to use the arc length formula.
Yeah.
Number 6. Typically, shaded region problems are subtraction problems.
Yeah.
I say typically because not always. I must have already taken a picture of this. Yeah, sorry. I'm jacking around here. Oops, hold on a second. What the heck's going on? Ooh, computer's in dread. Huh. I seem to be frozen. Let's see if I can do anything at all here. Oh, hold on a minute. Let's see if I hit some of these buttons. Let me see what happens if I hit Control-Alt-Delete. Bring up Task Manager. See if I can get unfrozen here. Let's see. Photos. Let's end that task. Trying to figure out how to solve this without having to reboot my computer. Let me just close each. Let me close each of these out. Probably going to have to close out, go to meeting. And I will, once I close it out, it's going to give me a new meeting ID number. So I'm going to have to resend it to you. This whole process should not take more than 2 minutes. So I'll close it out and I will re-text you the meeting. No, I'm not. I forgot we're on the phone. You don't need to go anywhere. Here, I'm going to close out, go to meeting.